Hello and welcome to this short demonstration of our tool SiMPOSE. Let us now take first a closer look at a motivational example. We have a program variant which needs to be tested. Thus we introduce a new test case 1, which covers the basic blocks. Now if we want to test the other path, we need another test case 2. So now we change this variant to other variants, for example variant B, variant C, and a final variant D. Both integrate a new non-negative test in our program. Now we want to test all variants at once by reusing the test suite we created for variant A. But for covering the additional statement which is created in variant C and D, we need another test case 3. Now our test suite covers all statements among all variants. SiMPOSE takes as input n arbitrary program variants, merges them, and allows for family-based analysis, for example testing. Let's now take a look at our tool SiMPOSE. We have imported our example project into our SiMPOSE tool. This consists of a code and a config folder. For example, we have this busybox folder consisting of several functions. We will now take a closer look at the eject function. It will be used as example for now. Configure SiMPOSE, we open the pipeline properties, where we can select the input folder and, for example, some different merging strategies. To this end, we can select the match partition, match all or subsets, and we can select the partition strategy, how to partition these subsets, for example randomly or using similarity. Or we execute SiMPOSE by selecting the application. The current state is printed in the console. For example, you may see what input programs are used and how SiMPOSE converts the programs into control flow automata. Then test suites are generated for the variants, the program variants are merged by SiMPOSE, and finally the test suite for the merged are generated as well. We can now inspect the output generated by SiMPOSE by refreshing our example project. It consists of the output folder for the merged program, the test suite folder for the test suites. Let us now take a closer look at the merged programs. We open the graphical representation that is available for the variants and the merged eject function from busybox. We can see merging all n variants simultaneously leads to a common path between all 4 variants, and the states and edges are merged until this separation point. As you can see, the variants differ in their, for example, parameter. So there are 2 paths which are split up. So we have this left path and we have this right path, which consisting of 2 variants. Both are rejoined at the bottom of this function, which finally returns the value as needed. Additionally, SiMPOSE generates the test suites for all functions and the merged function as well. So we now open one variant log file from the test suite and we search for test cases. As you can see, this variant test suite consists of 2 test cases. And the merged test suite, on the other hand, consists of only 6 test cases, which is a reduction as compared to variant by variant testing. So we now configure SiMPOSE for different merging strategies. To this end, SiMPOSE allows for an arbitrary name, as well as a merging partition size and the subset partitioning strategy. For example, we might want to do a 2-way merge, so we use this partitioning strategy in SiMPOSE. Then we can execute SiMPOSE as before and get the results for all different merging strategies. For example, we might partition our n variants into n-half subsets and select different partitioning strategies. For example, we might want to select similar variants as subsets or dissimilar variants. By refreshing our folders, we can now inspect the different merging strategy results. For example, we select our output folder and inspect our merged programs for the last strategy. For example, our subset dissimilarity strategy yields 2 merges, both differing to our initial merging strategy. Comparing the different test suites for each of the merging strategy in SiMPOSE, we can now generate plots for easier inspection of the results. This generates an HTML file which can be opened with any browser. You can see the testing efficiency and effectiveness are presented in different charts. For example, you can see that all merging strategies are better than variant by variant, but the n-way merging strategy the highest efficiency regarding test suite size and test suite generation time. This is also the case for the time per test case needed for generation. Regarding effectiveness, we can see that though we got some timeouts for each of the merging strategies, we achieved the same goal coverage by using less goals overall compared to variant by variant. Thanks for watching this demonstration, and we hope you got an impression on SiMPOSE and its tool functions.